So first, I will tell about myself. I have been in this field since 2014. I have combined 7+ year experience in data science. I work as a data analyst for a US-based educational company, and they provide deep learning and machine learning methods for grant allocation and optimization. I also work for a Netherlands company, TriLabs, as a data scientist, and I work in the retail sector to provide data science solutions and to create reports. And I have also worked on for various companies like in Singapore for a retail company and in Canada. So my domain is majorly in retail and education sector, and I also work in IoT and healthcare. So the training agenda is to get an overview of data science and what is the workflow of data science. Who is actually a data scientist and who can be a data scientist? What are the skills required for a data scientist? What are the roles and responsibilities of a data scientist? What are career options for a data scientist? And what is the salary trend, which is really important? And scope of data science in the market. Different sector industries where data scientists can be employed. Companies hiring data scientists and data science trend in 2017. And what are the certification we can achieve so we get exposed to the market. So the modules for this course are Introduction to Data Science. We will see what every jargons of data science and what are the methods and methodologies used in the data science process. Then we'll go into R programming. R programming is really R2 programming language in today's world. Basically, two programming languages are used in open source environment. One is R and the other is Python. And the third module is statistical interference, where we will see how we can make conclusions from the data and how we can create some predictions using statistical techniques. And the fourth module is exploratory data analysis. Exploratory data analysis is a way to diagnose the problem in data science, or a way to explore the data. Like we are like Sherlock Holmes, and we are going into data and seeing what are the options and what are the trends we are seeing in the data. So we can create some sort of picture in a descriptive way. Then we will see 3 basic machine learning algorithms. Then we'll go into data visualization, which is the most important part in the data science, because if you cannot create visuals of your data, then it is not possible to communicate in an effective manner. And then we will see Introduction to Statistics. Statistics is very important in data science. It is really the basic step to learn the data science process. Then we will see hypothesis testing and regression analysis. And then we will go into clustering and association. And then we will see data testing and assessment. It is a way to evaluate our data science process. So this will be our journey. So what is data science? Before going into definition, I will give you an example. Like few days back, I was giving a workshop in Delhi, and I met my friend. He came to me and asked me a question, like how are things coming to me which I am thinking about, or even I am searching. Like I said, how? So he said a few days ago I want to buy an insurance policy, and a company started calling me. And then I wanted to buy a property, and the real estate company started messaging me and calling me and giving me emails. So if the world is really getting my information, or I am getting some powerful psychic powers. So I said, no, this is not possible, because it is purely a data science. Because I said, what you have done in the last few days? He said, I browsed the web for the insurance policies, I browsed the web for the real estate. So there is the data. So the companies like Google use the search engine data and create customized marketing, and that's why he's getting what he wants. So data science is basically used in all sort of domains, especially in marketing field. Google is using this lot of years, and we don't even recognize it, and we are searching for insurance policy, and an insurance company few days after call us to tell us the policy, and we are amazed like how they know, like how they know we want to buy a policy. So basically this is the outcome of data science, and it's very amazing and surprising to it. So what is data science? Data science, also known as a data-driven science, it is an interdisciplinary field about scientific methods and processes and system to extract knowledge or insight from data in various forms, either structured or unstructured, similar to data mining. It is an emerging field that focuses on an automated machine and techniques to analyze large amount of data. This is really a formal definition. Like if we go into detail, we will see, and we can bifurcate this definition into particular parts. Like it is a data-driven science. So why we are calling it science? It's not physics, chemistry, and biology, but we are calling this science because science is a way to experiment and go into environment and record that data and see patterns, and the formulas are written in those patterns, and the science is basically to find those formulas in those patterns. Like there is a Newton's law of motion, like F is equal to ma. How this was formed? It was formed basically because of the data that the scientist that calculated that, and he found that there is a pattern among the relations in F and ma, and formulated a formula F is equal to ma. So this is science, and the same way in the data science, we try to get formulas from the data, or we create formulas that we can apply to the new outcome. So we have a formula to, like, we want to predict y, and we have x and z, and by training the data we get to know a formula or a method by which we can get set y from x or y. So these are things we are actually deriving a formula from the data, and it is a data driven because we are using data to get the formula, not we are using any observation or experiment, and we are using the data which we get, and we model it, and we get some formulas, and we can apply it, and we know the outcomes, and we can make the predictions, and we can do different sort of things. Is an interdisciplinary field. Interdisciplinary means the data field does not exist on its own. There are academics involved, there are professionals involved, there are a lot of fields that are making the data science. There is machine learning, there is math, there is physics, there is programming, there is algorithms, there is stats, there is probability, and those fields, after combining them and they getting the important parts from them and making this subject as a data science. To extract knowledge and insight from data in various forms. So basically data science is the process to extract knowledge and insight. What is the meaning of data science without getting knowledge? So basically our motive is to get the knowledge or insight. Like if I have a project, and if I hire a data scientist, I will ask him like what you can do with this data, what information you can give to us, and what type of knowledge you can give to us, and what you can do with this data. Because data itself is nothing. It is important, really. You have a lot of data, but without getting the knowledge from the data is nothing. So it is very critical in data science to get the knowledge and insight from data. And data does come in various forms. It can come like a raw data, or a streaming data, or a data from social media or something, other platforms like an IoT device. So data is coming from various sources. It is either structured or unstructured, similar to data mining. Data can be structured like a Excel file where we have a tabular data, like every field had its own rows, and we have a structured form of data, and we see in a tabular way, and we can store it, and we can make relations with one table with another table, and we have such type of structure. For structured data we can see like this, like a data the retail company store of a customer, or a college store of a student. They store it in tables, and this is structured data. Unstructured data means unstructured data is actually contribute 80% to the market. There is like unstructured data is text, videos, images, and anything which cannot be stored in a table like one field like name is storing the names. There is no such thing in unstructured data. The Twitter tweets data or Facebook comments data, it is an unstructured data, or Facebook photos or your photos in phone or videos. It is an unstructured data which contributes to about 80% of the data in the present world. Similar to data mining. Data mining is also a field where you get knowledge from the data. It is very similar, and it is data science actually built on the foundation of data mining. It is an emerging field that focuses on automated machine and techniques to analyze large amount of data. So years back we have really a small subset of data like 500 and 1000 rows, and data collection was not really important. People are not giving importance to data. So a lot of data was wasted, and now the data is generating at such a high speed and in such a round, like every day people are doing things, and even a smartwatch, people are wearing smartwatches and they are collecting lots of data. So there are methods that have been made and everything has been computerized. So even you go to a shop and your data is recorded every day. So data is increasing day by day, and we need to really find ways to store it in a perfect way. Like there is lots of video content over the YouTube, and how the video content is stored. Every day people are uploading their videos. And we will see later in this course that the techniques which can be used on a small size of data cannot be applied to large size of data. Those techniques fail actually, and they are hard to scale. So we will see how we can scale those techniques on the big data part. So here in the diagram we see a traditional approach to data analytics and a modern approach to data analytics. So what are the changes? Like we see the first block. They are actually new data source and format. Like in the traditional approach we see that there were tables, files, text files, raw files, CSV files. Now we have different connectors for data. We can get data from social web by using their API, like LinkedIn provides API, like Twitter provides API, Facebook provides API. You can fetch the data and you can use in Python or R directly and do the data science. Even like in traditional, both approaches have MySQL, SAP, and ERP data, but the new thing that has come into this modern approach is streaming. So what is streaming? Like there is a campaign is running, and the election campaign, and someone wants to know what is the feedback or what is the sentiment of that campaign. Even we saw in like any cricket league or any football league, we saw that there are lots of tweets have been made in 1 hour, and someone wants to really stream those tweets into our machine learning algorithm and get the data information or get the output from that machine learning algorithm. So streaming is basically we are streaming the data in real time. Like IoT devices are sending data regularly, and they are streamed like a video is streamed. So in the same way data is streamed, and there are lots of techniques that are developing today to stream the data so the data does not lost. There is no lag in the data. There is no timestamp loss. Another evolution in the new modern approach to data analytics is new data architecture. So in the traditional approach we have structured data, entity relationship. So what is entity relationship? It is a basically graphical relationship between the tables, and in the modern approach we see structured data, unstructured data, semi-structured data, and machine data. So structured data, as we already know, that it is a data in tabular format. We have all the columns specified, and every column has its own data, and like a name has the name field has a name rows, and the pin code has pin code rows. Everything is defined, and we have a tabular set of data. That is the easiest form of data we get. and the second is the unstructured and semi-structured data. And we know that as unstructured data comes in like photos, like videos, and text, books. All of this is unstructured data. We cannot store in a tabular format. We will see that in later that we can store some part of it. And semi-structured data is like the JSON data. Actually, it is a structured data, but it is not in the database table. It is like a JSON table or a data in the API or rating data in something. So it is a semi-structured data or CSV file. So it is structured, but it is not stored in the database. And the machine data is actually the data in the server or data in the RAM or everything. Like this is the machine data. And another thing has changed over the years, new analytical architecture. So years ago we don't have any approach for parallel processing. So parallel processing is, what is parallel processing? So we have algorithm, and an algorithm takes lot of RAM and lot of processing power. So what we do is we parallelize the processes, so we get the machine learning algorithm running less time than it was running before. So this is the thing that has changed. Distributed computing, we all know that the data is stored at distributed, different servers are created, different copies of data is created, and it is allotted to a distributed system. So, and in memory analytics is the analytics on the data stored in the RAM. And new techniques have been evolved like predictive analytics, data mining, and clustering and segmentation. And previously we don't have those techniques. Like we have those techniques, but they were not implemented because of the computation limitations. And we generally do reporting, dashboards, and data analysis. So here is the graph. This is the graph between business value and analytics maturity. And we see that this programmers, business analysts, and statistician and business analysts, and these people jobs are really come into data scientist job. So data scientist is a really broad term, and they are specialized field also. So at the first part on the analytics maturity, we see aspirational and advanced. And the first part is really the programmer's job. So the programmer's job is basically to really create the data or store the data or get the transaction. Means transactional data is like it has a time and a value, like a business transaction or a bank transaction. And those data need to be stored with a quality maintained. Like we are entering a form and somebody has entered a wrong phone number or a wrong PIN code or a wrong state, and we need to maintain that quality data. So this is basically the programmer's job, and it is really the basic step in data science process. Then we see the descriptive part, which also coming in the business analyst thing. The descriptive part is like you have the data and you want to describe that data to someone. Like you have like you go to a car showroom and they have a car and they say only one thing about the car, and you get the whole idea about the car. Like this car has 35 miles, this car gives 35 miles per liter, and you get like whole idea about the car and you think that this car is really good. Same thing is in the descriptive analytics. You tell things about the data that give the clear picture about the data. You don't give everything about data that like I have this GPA, I have this maximum minimum value. You tell those stats and those things which really matter to a person. Like if I have to ask something to you, like what is the special thing in my data, and you tell 2 or 3 things and I get the total picture. So this is really important part, the descriptive part. So we are seeing that this graph is increasing, and this line shows the process of data, first the data quality, then the descriptive, then the diagnostic. Diagnostic is like seeing what are the problems in your data. So we are seeing, like, for example, we are solving a housing problem. Like, we want to predict at what price our house must be sold, and we have the data of past houses and with the same number of roofs and everything, and we see what are the things really important to us. Like, is it really the floor area, or is it really the garden area, or is it the number of washrooms that rooms have? So we must identify those factors which are responsible. So we are diagnosing the problem, or someone asks us, like, what is the problem in my data? Like if a company asks you why my employees are leaving the company, and he gives you the data and you diagnose the problem, like this is the reason, like their salary has not been increased in 7 years, and you saw that in your data, and you say that, yeah, I have diagnosed that problem, and I see that this is the problem. I have identified those factors. So then is the predictive part. Like, you have diagnosed the problem and you want to really predict. Now the next important step is to predict. Like, I have like 10 years of data and want to predict for this year what will be my outcome. Like, I have 10 years of sales data, and I want to know, like, how much I am going to earn this year. And we will do predictive analytics, and we calculate probabilities, like you can earn like 50 lakhs this year with some accuracy, or we give some type of error value, like you can earn 50 lakhs rupees with a error of like 1 lakh or something. So we see all the machine learning models, and we see all the advanced stuff here. Then there is a semantic, like what we need to understand, like we need to understand the data, and we need to understand the text data, and there is network data, geospatial analytics, social media analytics, sentiment analysis, and images. So in this, like, you are getting data in another format, like a textual data. You are getting the textual data. You get the network analytics. Network analytics basically, like, you are identifying the problem in your network. Like, network can be anything, like a Google Map. It is also a network, or a supply chain problem. It is also a network, and you want to optimize the network so that you get the maximum value from the model. And geospatial data analytics is basically done on the map. Like, you have all the states on the map, and you want to do some type of, like, you have the satellite imaging, and you want to see how things are distributed, and you want to predict, like, these type of analytics are done on geospatial analytics. Social media analytics, we know that, like we want to see how many users are clicking our post, and how I want to predict how many viewers can be possible. Like, you go to Facebook and you want to promote your post, and it will estimate the number of viewers you can get by selecting the interest. And these things is done in social media analytics. And even like we see that any movie is released, or any league is created, anything, and they create promotion, and they want to know what is the impact of them on the social media. Is it positively affecting the crowd, or is it negatively affecting the crowd? So this is the part of sentiment analysis, actually. So in sentiment analysis, we will see, like, and we will do in our, like, we have the data, and we want to see that is the feedback of any customer, or even the Twitter tweet of any person is looking like a positive tweet, or is it looking like a negative tweet. And these things are really important in making the awareness, or making the really value. I have a company, I am running a campaign, and I want to know whether people are giving me a good reaction or a bad reaction. Even any company launch a phone, they want to know that what is the reaction of this new phone we have launched. And we have the images data, and we have seen that all that of image recognition stuff is going on. People are using image recognition to do different sorts, like photo tagging and recognizing different objects. Even they are doing in real time. And on the advanced stuff, we see that there is understanding pattern and data visualization. Data visualization is, as we know, is really important thing. And every day we see in newspaper that some sort of data visualization article on like Kerala floods or any election campaign or anything we see that that a great picture is created in the article, and there is a lot of work that's done in that article or in those pictures, in those charts, and we may ignore that, but this is really great field and it requires really artistic approach. And this in data visualization where we can even identify the problems without going into stats. We can see that this bar is high, this bar is low, and we can see in relationship with other bars, like we are identifying an educational problem, like why students are failing, and we see that we create different plots of students, like what are their GPAs, what are their sports interests, what are their program interests, and we saw that like the student didn't get their program of interest, that's why they are failing in their subject, and we have only diagnosed the problem using the data visualization. And we see that on the x-axis there is programmer, business analyst, statistician, business analyst. So business analyst basically a person, if I have a data science project and if I want to send someone, like I will not send my programmer, I will not send my data scientist, I will send my business analyst to understand the problem in that business. Like if a Walmart has problem, I will send a business analyst to them, like go and see what are their problems and what are the problems we can solve using data science. So business analyst will have the business acumen and business knowledge of that, and he can tell us like this is the problem and this is the way we can solve the problem. Then the other people come in like statistician, data scientist, data analyst, programmers, and they all contribute in this field. So data science is a multidisciplinary blend of data inference, algorithm development, technology in order to solve analytically complex problems. It is ultimately about using data stored in enterprise data warehouses in creative ways to generate business value. So it is a multidisciplinary field. We know that this field is made from a lot of fields behind it, like math, stats, probability, and programming knowledge, algorithm knowledge, data storage knowledge, everything comes into play, and those things create data science. And we need to create an algorithm based on those values or on those things, and we have to develop an algorithm and to derive knowledge from that data. And algorithm development is a really important part in data science. And you have an approach or your research paper, and you want to apply that research paper programmatically, and you want to develop that algorithm. Like I want to optimize my problem, I want to optimize my losses. I'm a businessman and I want to optimize my losses. I need to develop an algorithm. And so algorithm development is a really crucial part of data science. And we are solving like analytics. We are solving problems analytically. We are not doing any guesswork. We are thinking in a data science way. So data science mentality is more important than data science skill actually. If you can look a problem in a data science manner or in a data scientist way, then you can also solve that problem. With only knowing the tools, you cannot solve the problem. You have to have a data science mentality. It is ultimately about using the data, and data is actually like a fuel, and without data we cannot run to data science. Even if we have powerful algorithms, even deep learning, advanced machine learning algorithms, they all require data. Without data, there is no data science. We have a question like, so how are the job opportunities for data science in India? Like, very good question. So there is really a huge opportunity in data science in India, because India is really a big country. There is a lot of population in India, and with the population, the size of data is really high. And with that data, the companies are coming in into India, and they want to use that data to create values. And India is really a high market. Even Facebook, Google, all focus on India to create businesses. And data science is more important in India because we have the population, we have the data, and the data is created every day in a huge amount, and any solution that can be applied to India can be applied to anywhere in the world, because that solution will be a scalable solution. So data science opportunities in India is really fantastic, and a lot of companies are really converting into data science companies, and even they are finding how they can apply data science in their method. It is not about really creating a data science startup. It is really finding a data science solution in the existing problem. Like I have a existing solution, I want to give AI to it, like I want to give data science to it. So a lot of companies in telecommunication, whether it's healthcare, and whether in marketing, whether in sales, whether in education sector, data science is really there, and there is a lot of opportunities in data science. So in this flow chart, we can see that data warehouse is basically the first part. Data warehouse is like you have a data stored in the SQL or in the CSV file or server, and the next step is discovery of data inside, called quantitative data analysis to help strategic decision visualization. So insight is basically what can help businesses. Actionable insights can help business, and we are here to really extract the information from that data. Without extracting, we know that the data is no use, and we know that extraction is basically this part. And we in this course we are going to learn about the data extraction part. The data, how we can create values, and which methods can be used on the data. And we can see, like as a toolbox, like we have different tools for different problems, and we want to learn those tools, and we have to recognize those problems so we can use the correct tool from our data science toolbox, and we can fix those problems. So this data science is not only about how data is stored, how data is collected, it's also about using the right tool to fix the problem. Development of data product, algorithm solution, production, operating at scale. Like the product is really the important part. Like we have done the data storage, we have done the discovery, the algorithm part. Now how we can communicate or even sell that product, and that's where like developing a data product come in handy. Like I was doing for a retail company a market basket analysis, and the problem was that they want to know which products are sold with the other products. Like for example, there is a McDonald's. They have a meal, like they are selling French fries with cold drink and burger, and they have created a meal. And what they must have done, that they must have sorted what are things bought with the burger or French fries is not selling. So we need to see like what are the products are bought with the French fries, and we thought that the cold drink is bought, we thought that the burger is bought, and we have created a meal. So there is a market basket analysis on substitution rule. We are selling the weaker, we are combining the weaker product with a stronger product to sell both of them, and we are increasing our sales. So they wanted me to develop a data product. So there we can see that they can select one product and see how what are the probabilities of other products that can be sold with that. So data product development is really important. There are tools in R like Shiny. Using Shiny, you can create prototypes of data product in a really interactive and efficient manner. Even you can insert big data into it also using the libraries in R. So R Shiny is really a good library for creating data products. And all those things give business value. Like if I have created a product and it is not giving a business value, it is not saving me money, it is not creating me value, it is not giving me enough profit, even knowledge. So that product must also give business value. All this process is done to get the business value. And the example we see that Netflix data mines movie viewing pattern to understand what drives user interest and use it to make decision on which Netflix original series to produce. So Netflix actually uses the people interest and their user interest, like if they are liking the action series and they are more towards subscribe to the action series, and it helps them to really to create that type of series. So they like to know what are their users' preferences and interests, and they really customize. I mean, they create those products which are more replicable and sellable. Another example is Amazon recommendation engine. Like, this is the most common example we all must have seen. Like, we are going to Amazon or any shopping website, and we saw that products are sold, and we scroll down to a page and there is a recommendation list of products. And what Amazon is doing is really recommending other products based on our interest, and not recommendation engine is not only used in the shopping way. Like if you go to Facebook and you see that the suggested friend is they are also using the recommendation thing. Even the insurance, you go to buy insurance policies on any online shopping websites, like or any online way, like you want to buy insurance policy and you go there and they suggest you based on your habits or based on your form which you have filled. So recommendation engine is used everywhere, like this algorithm is really powerful. You can see recommendation is built in every part of the shopping website, or there are a lot of things that lot of amazing products have been created on recommendation engine. So we have a question like is there a specific prerequisite to learn data science? So this is also a very good question. Like if you go to search online, like what are the prerequisites for learning data science, you will get a list of things like you need to know Python, you need to know R, you need to know programming languages, you need to know databases, you need to know maths, you need to know linear algebra, you need to know calculus, you need to know multivariate calculus, you need to know linear optimization, and you need to have also business understanding of the problem. But all those exhaustive lists, like you cannot learn in one lifetime. And I think what is your strong point, you can take that point into data science. If you are a good programmer, you can take your programming knowledge and start with programming knowledge and use that knowledge in data science. If you have a good math background, you can use math background and get into this field. If you have a good business understanding, then you can use your business understanding to get into field. So even you are coming from any background, like this data science is used in every field. Like people are training their employees to in their companies to learn about data science, so they can apply data science in their job. So there is no prerequisite. Like you need to have more of a business, analytic mindset than a skill, but still the skills need to be learned over the period of time. You need to fill those gaps. Like math is also necessary. If you guys like to go into deep learning or core data science, you have to know math. You need to know linear algebra. But to start data science, you don't need to know all those things. You can start whatever your strong point is, and you can go into this field. Even I have taught people from biology background, and they have applied the machine learning algorithms in their even without knowing the mathematics knowledge, because the mathematics comes later. First, you have to get the understanding of what this algorithm actually does. So prerequisites. If even you don't know programming, you can start with it. So there is another question. I am a fresher. How can I learn data science as I have less programming knowledge? So even you have less programming knowledge, you can start data science with Excel. Even R is really easy to learn. There are a lot of resources available. Even in this course, we are going to learn R with a hands-on approach, and we will see lots of examples to learn R. And R is really the basic step to learn. It is a programming language. It is a tool to do data science. It is not a data science. It is actually a tool to do data science. And you can even start with basics of R, and then you can enhance or increase those skills when you are doing data science. And then you need to learn stats, and we will have a hands-on approach. Like, you will learn all things. What are the things required? You cannot, like, if I ask you to learn about a TV, you don't learn like breaking those pieces and learning about the resistor, transistor, and LCD. You actually start with the overall picture, like how this works, and then learn about detail by detail everything. So same thing happens in the data science. You need to start with basic like R or Python, and then basic knowledge of stat, and you get started in this field. So even you are fresher, even you have never coded before, you can really excel in this field. In just 6 months, you will have all the knowledge necessary to be a really professional. But this field is really changing and evolving, and we see that the new libraries are coming daily basis, and we need to update ourselves to new libraries, what are the new libraries are coming in, and what are the new methods are coming. We need to keep ourselves updated because this field is really evolving now. So what is the data science workflow? Like for every approach or everything, like we have a workflow, we have a way to do things, and we have like methods to perform any activity. And data science workflow will tell us how to perform those activities. So first is the data acquisition or cleanup part. Like, you need to get the data first. Getting the data, even you have the data, you have to store it in a proper way, in a proper format, or you need to store it in structured data format. Or data can come from different sources. It can come from a machine. It can come from a retail company who are filling customer details when they are buying products. It can come from IoT devices. It can come from in a video format. It can come from photos. So data is everywhere, and data acquisition is really crucial important, and especially the data we want is more important. Like, if we want to solve any problem, and we need to have that type of data, like we need to identify any disease and using their X-rays, and we need to have those data labeled. So data collection is also really important part if you want to solve like automate like X-ray screening, and you want to give a machine X-ray and decide, let the machine decide whether you have a disease or not. Then you need to have such type of data also. So data acquisition is really important. Without proper data acquisition, the data process does not start. Cleanup. So actually cleanup is also important. Like, you have the data, and data does not come clean. Like, there are problems. Even you see any field, like even the data is filled by any person or anything, there are problems like the date of birth is wrong, the PIN code is incorrect, the format is wrong, the state is wrong, and you need to clean the data. Even there are outliers in the data. Like, we have salaries of the employees, and every employee is getting like average 50,000 salary per month, and we see one employee is getting like 2 lakhs per month, and he is actually an outlier. Sorry. And if we are going to take that person into our data, we are getting skewed data science solutions, because that, even if you calculate the average, that average will be deviated to 100%, but it doesn't give you the real picture, and that affects the modeling part also. And we need to clean those things. We need to clean not only the dirty part of the data, but also clean the outliers or the minimum points or the maximum points, so the data is really in the uniform format. It should have some sort of uniformity, some sort of generalization in the data. So it should be a generic type of data, not a like you have extreme values in the data, and that will affect the whole process. So it can take about 80% of time. I was actually working on for a university in US, and they have their data, and they have several years of data, and the data is coming from the financial department, the enrollment department, the academic department, and every data is coming from different sources, and we have to merge that data. And we saw that there is a problem in data. There are multiple IDs for students, and students are enrolled for multiple programs, and every year there was mismatching of IDs, and there was so much problem in the data. It took really 6 or 7 months only to solve that problem in joining. So it took almost 80% of our time to really clean the data, and it's really frustrating, and it's really the most important step also. If you don't clean the data, if you don't spend time on data acquisition and cleanup, all the other processes will fail. Second is storage and management. If you have a lot of data, you need to find right tool to store also that data. If you have big data, then you have to use big data solution. If you have small data, then you have to use MySQL or anything else. So how you are getting the data, like you are getting the video data, you are getting the photos data, or you are getting the data from the sensor, and you need to properly store them in a way so that they can be easily fetched. So data storage and management is really important. And third is really analysis. So we have saw that you have the data, you have some data in the warehouse. Now you need to do analysis. Analysis, and it is really a iterative process. Like if the data is not sufficient for analysis, then you go back to data storage and management, and then ask that hey, the data is not sufficient enough to make me any sort of addition or any sort of claim, or any sort of calculation. So you need to get those feeds. You have not those. You need to get those feeds. So you ask the data storage or management or data acquisition to get those feeds if it is possible. And in analysis, we see that there is open source analysis and there is a closed source analysis. So open source is basically R and Python, and closed source is SAS. And there are a lot of companies that are creating like closed source solutions, but the most famous are the open source, because if I'm starting any company and I want to hire a SAS programmer to buy after buying a really costly SAS program, and that will really increase my expenses, I will go towards open source, because a lot of resources have been available, and I can have every library for everything, and there are people who are continuously contributing towards the R and Python and making it really valuable. But really in some sensitive application, people don't use open source, because there is no reliable person. Like if there is a bug in R, whom you will blame, because the R community will fix it in few months. But if you have a paid solution, and you can ask those people like, hey, there is a problem and you need to fix it because we have bought this expensive software. So in sensitive application, really people are using those expensive software. The fourth is really visualization part. And there are a lot of libraries like DPYR, it's a JavaScript library, and there are libraries in R like ggplot2 and plotly, and there are many other libraries, really great libraries, which can help you create customized visualization in a very in a 2 or 3 lines of code. You are able to create customized visualization, and you don't need to rerun those analysis. You have created one code for one graph, and every time you have the data, and you could go through that code, and the same graph or report is created. So visualization is really important, because I've also told you that if I have to tell one metric about my data, and I ask you how is my data, and you will need to either you need to show me some chart, or you need to give me some insight. So there's another question like, what are the salary ranges for freshers in India? Like, so we have a section on salary ranges, but for India, the salary starts from like interns are getting 20 to 25,000, and the salary really goes up like 50,000, 60,000, and people are earning like 1 lakh and 2 lakh rupees per month using on the senior level position. But the salary begins like from 25,000, and it goes up like if you are a fresher, you will be able to get like 25 to 40,000. And if you are a senior person, the salary goes really up, and you are really paid on the basis of hours, like if you are still a freelancer. So this is a really highly paid job, I think, and if you compare this job with other jobs, and you compare their salary with data science salary, you will find that data scientists are paid much higher than the other people. But the entry levels, like you have to start with like 25,000 to 30,000, and if the company is good, you can get 40, 50, 60,000. It all depends on the company also. If it's a startup, you will get those salary. But you need to start in this field, because if you get experience, 6 or 7 months of core experience in data science, there are a lot of opportunity in data science. Every day you will get messages from companies like they want to hire you. I am in this field for 7 years, and every day I receive messages from people like they have a project and I don't need to approach anyone. They are approaching me because they know that I have the experience, and they want to hire people who have experience. Even you have 6 or 1 year of experience, this is really valuable for them. So you need to start as quick as possible. And the fifth part is really communication. And the fifth part is the communication problem. Even you have really created a complex algorithm for your data science process, and the critical part is really to explain the people like how this actually works in layman terms, because the person you are explaining this algorithm, they are not a statistician, they are not business analysts, they are not data scientists, and you need to explain them in a way that they can understand. Even your algorithms is really hard and complex, but you need to create in a way that they can really understand. And I was working I was in the start of my career, I was doing like a correlation analysis, and I reported to a manager, and he simply asked me like, what is correlation? There was significant correlation in the data, and really asked. I took a paper and a pencil and explained him on the paper, so then he understands the concept. And you should also be ready to really explain your part, and you should do in a way that you can explain in a very layman terms, so they really know that wow, this is amazing thing. And their collaboratives are like GitHub and Bitbucket. You can share your code, like 4 or 5 people are working on the project, and they can really collaborate with each other. Like on the one part someone is working, and the other part someone other is working, so they can collaborate and see other code. And we will see in this course like how we can use GitHub directly from our license. So that's for the data science workflow. So who is a data scientist? Data scientist is someone who is better at statistics than any software engineer, and better software engineering than any statistician. This quotation was given by John, and it is true also that you need to know stats, and you need to be able to do stats in a programming way. If you are good at stats and you don't know programming languages, then how you will automate that concept or program that concept, or even simulate that concept. So even if you are good at stats, then you still need to know programming language. And in this today's world, programming language is really, really important. In any field, you have to know programming language, because you need to save your time and you need to save your energy so that you can replicate the you don't need to replicate or repeat the work which can be done using code. So coding is really important in every field. Coding is really important, and in data science, coding is really important because it saves time. And because if we have created algorithm for one problem, we don't need to recreate the same process. We have coded that problem, and we can plug in another data of similar type, and we have the same solution. So we have spent our time properly, and we have one solution ready. We have passing other similar type of data by tweaking our code. So coding is really necessary, and stat is also necessary. Stat is really the basic foundation. You need to know like what is ANOVA, what is hypothesis testing. So it is really necessary because when you go to an interview or any explanation, you require some sort of explanation. Then you need to use stat term also, because we know that on the communication part, like the other person does not know stats and these things, and you need to go into layman terms to really explain them. Before going into layman terms, you need to know actually what is the process and what is the understanding and of that process, and you need to know stats to really know that concept. And we will see some of the stats in this course and how we can apply in our and we can do like big complex statistical techniques in our just one line of code. There is another question. Would you like to know if stats is also covered as a part of those? I think this course is designed for R, and I'm not sure about whether we are going to stats. Maybe check with them, check with the company for this. So what I know is that R is a language we are going to use. And even you are software engineer, then if you want to get into this field, then I mean for software engineers, they need to know stats and they need to know machine learning. And I think for software engineers it's a bit easier because they already know the coding and they have the logical mindset and they have the algorithmic approach towards everything, and they can really excel in data science with knowing statistician. I'm not saying that statistician cannot excel in data scientist, because R is really easy language and you can learn R really quickly. So we are already in the workflow, like collection we can use. Like we can move in the like there are libraries in R, like there are a lot of libraries in R to read the data from CSV file, to read the data from Excel file, and to read the data from JSON file, or even read the data from web or extract from API. In exploration we have like ggplot2, and there's a library in Python for math.x. Similarly for collection there is a library called pandas in Python. And the data wrangling is, there are a lot of libraries like DPYR, reshape, and in R and in Python we have pandas. Modeling is the machine learning part, and we have sklearn in Python, we have caret in R. They are really heavily used in both of those languages. And validation, we need to check our model, like we need to validate our model, then their modeling and validation are really done simultaneously. And the reporting, like you are communicating with your result. And we have like Jupyter notebooks in R, we have Shiny, we have R Markdown, we have Tableau to report that. And databases, like we have MySQL, MongoDB, Oracle, PostgreSQL. And for database selection, you really need to know what sort of data you have, and you have to decide which database you need to use. if you have big data, then you have to go towards like big data solution, and we have any unstructured data, then you have to use MongoDB and other unstructured data bases. If you have structured data, then you can use MySQL. And another thing is like big data, and for big data, Hadoop is used. Like big data is like the velocity, variety, and volume. If you have data, if a lot of data coming in 1 or 2 minutes a day, then it is called big data. If you have large volume of data, then it is also called big data. If you have variety of data and you have large size of data, then it is also called big data. So for big data, we have distributed system for storing, which is Hadoop, and then we have Spark to do machine learning on the big data. So who can be a data scientist? I think anyone can be a data scientist, and he can apply data science in his field. He don't have to leave his field to really become a data scientist. He can use his business knowledge or even his field knowledge and apply his data science skill in his field. So anybody can be a data scientist. So here's a list like experienced banking, insurance professional, like can be a data science finance professional. Like we have like fintech companies are coming up. They are using AI to product tools. Software developers, they have basically good programming experience. Testing and QA developers, they also have those skills. Professional working in government sector, they can also learn because they have worked with the data, and professionals who are working in government sector, they deal with lot of data. Business development executives, they have really business knowledge, and they can use their business knowledge to come into data science. Life sciences, like I've seen people from research, like they are really interested in data science. They want to use their data science into their research or anything. So people from the life sciences are also really interested in data science. Healthcare professional, like lot of solutions have been developed over the past year, like on the healthcare, whether it's smartwatch or automatic scanning systems or even pharmaceuticals. We see that people are using data science to really know the outcome of any experiment, or even to predict what will be the outcome of any experiment. So people are using in healthcare and manufacturing, and in automotive industry we already know that they self-driving cars. Teslas are used. Tesla is a big company which are creating self-driving cars, and they are really excelled in this field. And there are a lot of companies are coming in in this field. And retail is really a huge sector for data science. If you go into retail store, you will see data science everywhere, from shelves to customer behavior, customer feedback. Everywhere there is a data science involved. So people who are in their profession, they don't need to leave their profession. They can learn data science and they can apply data science in their field. And companies are training their employees actually to able to learn and see their profession as a data scientist. So we already see that it is an interdisciplinary field. It has been made by the combination of lot of fields, and data science is somewhere at the middle of these three fields, like this math, business, and information system. So this circle is using all the fields, and it is usually a subset of all those fields, and it is really at the middle of this field. You have to have math knowledge, some of them. You don't need to be a mathematician, and same way you don't need to be a computer scientist or computer engineer. You don't need to be a business-centric person. You should have some basic knowledge of all those, and you can really excel in data science. So it is really at the middle of something, and from all those fields, people can come into data science and play a big role. So what are the roles and responsibilities of data scientists? So data scientist is a person who really first cleans the data and manages and organizes the big data, because he need to know how he can, what is the data and what are the problems in data. He should be really good at creating descriptive static analysis to develop insight and build models and solve business needs. And he also need to understand the problem, like what is the business problem and you know, at what perspective I can look at this problem and what are the techniques, because he need to have a large toolbox and he need to have all the tools necessary for so that he can use according to the problem. So problem identification is really important, and then using the right tool is also important. Research is also important, because sometimes you get the data and you don't know the field, and you need to research and to get the knowledge of those fields, because if you are a data scientist, you may not be a professional of healthcare and you get a healthcare problem, then you really need to go online to research about those things and to get the answer. You need to be able to use large volume of data, like whether the data is coming from internal, external, or either combining those data sources. You need to know about the machine learning techniques. What are the machine learning techniques you need to use on the data, and how you can create that data, or how you can evaluate that machine learning method, or how you can really find patterns in your data, how you can automate that workflow so that the company don't need to invest a lot of money in one process, and you have created a solution from one problem and they can reason the problem. So you need also you need to have automation thing in your work, and you need to know how to automate the analysis you have done or other machine learning thing. Explain to key stakeholder based on their analysis. I have already explained that communication is a really important part. If someone is there and who do not know data science, then I should have the responsibility to explain him in a lay manner, so that he can know the knowledge, he can know the importance of data science and what I have done with his data. So what are the career options for the data science? So there is a question also, what is the hierarchy of position in data science? Like people will start with like an intern or a junior data scientist or a data analyst, then go towards senior data analyst, then become a data scientist, or some people directly became a data scientist. So really there are a lot of types of job in data science, like business analyst, data scientist, junior data scientist, system analyst, chief data scientist, software engineer. But the basic hierarchy is like you first became a data analyst, then you go to a senior data analyst, then you became a data scientist, then you became a senior data analyst, senior data scientist. So this is the hierarchy, and these are a lot of career options you can choose from, and all of them basically use same things, and there are a lot of things are going on. Like a data analyst of a really big company can have more knowledge than a data scientist of a small company, because it also depends on the problem what you are facing. It doesn't mean that data analyst does not have that knowledge as the data scientist have. Basically the titles are really confusing, and they are really intermixed at some stages. So the basic hierarchy is really the data analyst and the senior data analyst, then junior data scientist or a data scientist. So this is the salary part. Like KD Nugget done a really poll in 2016 about data science, and he saw that entry level people are getting $92,000, and mid level, like those who have 5 to 10 years of experience, are getting like 1,09,000, and experienced people are getting like 1,21,000, and the really experienced people are getting like $1,45,000, and the median salary is like 1,50,840, which is really still high for any type of job you will see across any other domain. And in this chart we see that the salary distribution across all the developed nations we have for the major countries. So what is the scope for data science in the For India, I've already told that there's a question like, what about the India? Like, I see like people are getting like started like intern 25,000 and then they daily excel toward 50,000. So the starting job for a business analyst or a data scientist like 45,000 per month. I see people like they are employed for like Tech Mahindra and companies like 45 to 60,000, 50,000 rupees. So it depends also on the company you are joining, but you need to get some experience also. If you need to really become great at this, even if you have 1 or 2 years of experience in this field, that can jump your salary like 15 to 20 lakhs per annum. You can easily get in this field. So because this is really the important for every data scientist, is really an important position for every company, and data scientist is creating a lot more value than any other person in the company because he is generating the business. He is the key person who knows all about the data. So these are the things done by different type of organization, like CloudLab named the top job in America in 2016 as for data scientists. And Harvard Business Review, we all know that they have like said that this is a success job of the 21st century. Like we have in the past, we have seen that software development was a really great field to join, and the same thing is happening in the data science world. Like everyone is in today, you will ask them, they want to be a data scientist and they want to learn this field because they know that data science will be in every company. Every company will require data scientists, data analysts, and they want to be a data scientist because the job market will be really high. And there will be if you get out and see the only field which is growing a lot is data sciences. Whether it is you see the courses, whether you see in articles, the articles which are written for any other thing, or any other concept, or any other programming language, or any other domain, you will see that this is really booming. You will see everything everywhere. You will see people are really contributing to this. And there is shortage of data scientists because this field has grown so rapidly that there is a lack of experienced people in this field. There are a lot of entry-level people, but they are really shortage. There is really a shortage of experienced people in this field, and this 79.7% is actually the shortage of experienced people, not the shortage of freshers. Because the fresher also, I advise them really to start in the data science, but as quick as possible, because this is the time really. After 1 or 2 years, you will find people asking how much experience you have. But in today's world, if you really have good skills, good knowledge, and you have a good GitHub profile, and you have done some project on your own, they will hire you at the first place. They will not let you go. And there are a lot of jobs listed. If you go to Naukri.com in India or even outside, you will see a lot of data science opening position have been done. Even people, this is a field where people are approaching this field. Like I have many colleagues who don't have to search for a job. They actually get a lot of messages from people around, like people from the different companies are approaching them to join their company. Even 1 year ago, Google called me for an interview for their company. So all the big companies are really approaching people who have experience, or even if you apply to them, there are a lot of job openings in data science field, even for fresher or if you have some experience. So best thing is really to update yourself, is to really create portfolio of projects. So what are the future prospects? Like technology is growing, there is a growth in data. Every day we have seen that different libraries have been come up, and there are a lot of applications like chatbots have been built up, like image recognition. There are a lot of work has been done in the image recognition. Few days back, Google has announced its deep learning library, and the reinforcement learning library, and they are really contributing in this field. And every day people are coming from different backgrounds, and they are contributing towards this field, whether it's image recognition, whether it's video recognition, whether it's speech recognition. So there are lots of work has been done in this field, and it is really a evolving field, and we will see a lot of update in this field, and we need to really adjust to this. And there are a lot of future prospects. This is the field for future. This is the field for upcoming 10 years. This is the field. This is the best time to join this field, because the upcoming decade will be devoted to this field. So industry, there are a lot of industries that are all retail. You go to retail store, you will find data science applied everywhere, whether they are sending messages on your phone based on your past experience, or they are evaluating your feedback, or they are producing product in their shelf. Retail sector is highly using data science. Financial services, like banks, are using which customer will buy the credit card or not. Based on that, they call your. Even they are using it for fraud detection, like fintech companies are coming, as I already told you, they are using AI and blockchain or other high technologies to really give proper solutions. Manufacturing industries is also using data science, IT industry, government sector, automotive industries, marketing field, and digital marketing. We have seen that like Facebook is using and Google is using their algorithm to really enhance the digital marketing, so that customized marketing is created. Like if I have a mobile phone company, I want to market my mobile phone to a younger generation, then I can select, and they have really a tool, and they have based on your searching and based on your things, like if you go to Amazon and you search for a few things, and sometime back, and you come to Facebook, sometime after you come to Facebook and you see that the same post has appeared in your newsfeed. So they are tracking you, and they are using your data to tell you, so that even the businesses are profited by this, and you are also profited, because you want that thing, and they know that you want that thing, and they want to sell you. Companies that are hiring data scientists. So these are the biggest companies like Google, Facebook, Microsoft. If you go to their job portals, you will find there are a lot of jobs on their sites, and they are creating platforms, and they are creating new tools every day on data science. And these are the biggest companies in this field. And we know that Google has Google Cloud, and Amazon has AWS, Microsoft has Azure, Facebook has its team which is creating a lot of like time series libraries and image recognition libraries, and they have really sophisticated team for this, and they are really excelling in this field. Walmart, ANBB, they are all like really heavily using data science to enhance their company, and they know that this is a field. If they use this field and they master this field, they will rule the industry for the next 2 decades. So these are data science trends in the last 10 days are really happening in 2018 as well. So rise of the algorithm economy. Algorithmics really like linears are using algorithms to use decision making they are using algorithms in decision making rather than depending on one person or even the guesswork. They are using algorithm to decide whether they should go for that decision or not. Sophistication of analytics data science. This field is getting really sophisticated, and we have a lot of tools available in data science. And we see that machine learning, deep reinforcement learning, and generating models, these are all trending in this year. So that deep learning is really going up, and we need to start this field by using this fundamental concept, and we need to know the fundamental concept before going to deep learning. Emergence of citizen data scientists, learning analytics. This is a really interesting thing. Companies like Google and Microsoft and AWS, they are creating tools so that even a software developer or any person with the knowledge, they can use their already pre-made tools, so they can apply data science in their company. So some day ago, like some student asked me like, sir, where want to see the data science going in the next 2 decades? I said that you see the shop in front of us. There is a small retail shop, and I know that in 5 years he will be using data science, because this field is really going up and everybody is coming into this. And even people are, if you talk to people, they really know about this. They may not know the real terms, but they know that these things are really happening. It is using the analytics IoT sector. IoT sector is basically capturing the data from sensors, and they are streaming into their analytics engine, and then analytic engine is creating insights. So there are certifications in like a data science. CloudLab provide professional data science certification in data science, and you can check more about their website. So there is also SAS data science certification, and there is a SAS big data science preparation in statistic and visual exploration certification. These certifications really help, because sometimes you go to company and they ask for you like what certification you have done. If you have do not have any specialized degree in data analytics, or they ask for you like what certification, and if you show them like you have done this certification, then it really impacts them. Not only the certification, if you tell about what you have learned in that certification, during that certification, what project you have done, so that really helps in getting a job in this field. So SAS provides a lot of certification in this field. So this is all about in this session, and I hope we will catch up soon. Thank you.